Hello and welcome back. In this video tutorial lesson, we're going to be looking at physics homework number 8, acceleration. Now, many of these concepts will fall under acceleration due to gravity, so let me remind you about a couple of the necessary equations we might end up seeing. I'll write them over to the side. Okay, keep in mind, now these were equations from our equation sheet. Equation number 8 was V equals V naught plus AT. Number 9 was X equals X naught plus V naught T plus 1/2 AT squared. Number 10 was V squared equals V naught squared plus 2A times the quantity X minus X naught. And number 11 was X equals V plus V naught over 2 times T. So just to kind of give you a heads up on this one, we're going to be using this one quite a bit and this one quite a bit, okay? We might use the other two every once in a while, but just let's be prepared for that. Number 7. It says a ball is thrown upward with a speed of 38 meters per second from the top of a building 240 meters tall. Yeah, let's draw a picture of this. So we have our building. Okay, we have, here's us. Throw a ball up, and then it's gonna come back down again. Okay, so that's the gist of the picture. Now, what I would do at this point is I would start with my concept. My concept is acceleration. Yes, I know that because that's the title of the homework, but if you didn't know that, think about it. You're throwing a ball upward. Well, what's it gonna do? It's gonna accelerate because gravity is gonna slow it down on the way up and speed it up on the way down. So what do we do with an acceleration problem? We make a list. Okay, now our list in this case, instead of X and X naught, will be Y and Y naught, V and V naught, A and T. Okay, so we're gonna make our list. Okay, now I'm gonna let Y naught be the height of the building, which we were told is 240 meters tall. Yeah, I'm gonna let the ground be Y, 0. Okay, so here's Y naught here, here's Y down at the bottom. Y equals 0 at the bottom. V, I don't know. The velocity is gonna be a function of its height in the sky and the time it's taken to get there. So we don't know what the final velocity is. The initial velocity was, I believe, 38 meters per second. Now, since it's being thrown upwards, it's positive 38 meters per second. When we get to part H and I, and the ball is thrown downward, now all of a sudden we're looking at negative 38 meters per second. Okay, now we'll get to that when we get to that. Acceleration in this case is due to gravity, so we're going to automatically put a negative 9.8 meters per second squared for A. And time is also unknown too. We don't know the times where it's going to be, well, anywhere for that matter. So those are things we have to figure out. All right, so now let's jump into this. Part A asks you, how long will it take for the ball to reach the ground? Well, here's what I'm thinking. You already know a change of speed. Okay, you know the initial velocity, you know acceleration. What we can do to find how long, because how long is time, what we can do first is find the speed using equation number 10. So let's try that first. Let's find the speed when it hits the ground, the velocity when it hits the ground. So V squared equals V naught squared plus 2 times A times the quantity Y minus Y naught. Okay, now I know that Y is 0 at the bottom. Okay, and we would square root both sides, and V, plug in some values here, we're going 38 plus 2 times negative 9.8, okay, times negative 240. Okay, take a second, put that in your calculator. Now I see this part right here. This minus times a minus is a plus, so I'm going to be adding all that in there, and I did forget the square there, so I got to put that in there. So I have 2 times 9.8 times 240. So that's 4704 plus 38 squared is about 6,148. When I take the square root of that, I get roughly about 78.4 meters per second. Now that's the speed, mind you, okay? This would be the speed, the absolute value of. So we got to be thinking now, since the ball is going downward when it hits the ground, the velocity would just be a negative version of that, the negative accounting for the direction. So the speed is the absolute value, or just the magnitude of velocity. The velocity needs the negative to indicate direction. Okay, so now what we can do, we will use equation number 8. V equals V naught plus A times T. And we're going to solve it for time. Now to do that, we're going to subtract V naught both sides. We get V minus V naught equals A times T. Then we'll go ahead and divide both sides by A, and we will have an expression for time. So time is equal to V, which is negative 78.4 meters per second, minus V naught, which was 38 meters per second, all divided by A, which was negative 9.8 meters per second squared. Okay, so we have negative 74.8 minus 38 is negative 112.8, divide by 9.8 negative, and we're looking at about 11 and a half seconds. Okay, now keep in mind, this is not the only way we could have done this problem. Okay, it's the way I chose to do this problem. Another way we could have done this problem is we'll take it into 2 parts. Find the time it takes to get to the top, knowing that the speed at the top equals 0, and then find the time it takes to go down from the top. Okay, and then add those 2 times together. That would have worked as well. Okay, and now another thing we could have done, taking into account the whole pathway there, we could have just simply jumped on, instead of 2 different equations, we could have done number 9. Now the way you would have done number 9 is this. Show you over to the side here. Okay, we would, instead of x, we would have used y equals y naught plus v naught t plus 1/2 at squared. Now since you're solving for time, and time is quadratic here, what you would do is plug in numbers for these values. So I would have 0, 240, 38, okay, and negative 9.8. So this would be 0 equals 240 plus 38t minus 4.9t squared. Where am I getting 4.9 from? Well, 1/2 of 9.8 is 4.9. Okay, and then if I just, put this into quadratic formula, this would be A, this would be B, this would be C, right? And I would put it into quadratic formula, negative B plus or minus the square root of B squared minus 4AC all over 2 times A. So if I were to put this right here and right here, okay, and then if I were to put this right here and right here, and if I were to put this C for that part right there, and evaluate this, well, guess what? I'm going to come up with the exact same thing, which is 12 and a half, or 11 and a half seconds. So you have multiple ways of figuring out part A. Okay, again, I'll point out those multiple ways, but you need to have a strategy you're comfortable with. I kind of like using two smaller equations. That's just my preference. Okay, now in part B, it says, how long will it take to reach the highest point? Well, what do we got going on with B here? So to reach the highest point, V equals 0 at the highest point. We're going to use that to our advantage. So I can use V equals V naught plus AT, knowing that V equals 0 at the top. So 0 equals V naught plus AT. We're solving for t, so I'm going to go ahead and subtract V naught both sides. Okay, and we get negative V naught equals A times t. Divide by A. And time going up is negative V naught over A, which is negative 38 meters per second squared over negative 9.8, sorry about that, that should just be meters per second, over 9.8 meters per second squared. So 38 over 9.8, right, and we end up with about 3.88 seconds. So the time to go up is about 3.88 seconds. Okay, part C, we'll work that out over here. Part C is now looking how long after the ball is thrown will it be at 265 above the ground. So we're kind of doing the same thing, but instead of letting y be 0, you're going to let y be 265. That's what we're going to do. Okay, now let me actually try this problem using the using this method here. So I'm going to let, so y equals y naught plus v naught t plus 1/2 at squared. So y would be 265, y naught would be 240, v naught I'm going to plug in 38, and a I'm going to plug in negative 9.8. Now let me go ahead and plug all that in. Normally I would solve and isolate the equation first, but anytime it's a quadratic equation, just go ahead and plug in. It'll be easier to solve the quadratic equation using quadratic formula. So 265 equals 240 plus 38t minus 4.9t squared. So I'm going to go ahead and subtract the 265 here so that I can have 0 on this side. Okay, so when I rewrite this, I get negative 4.9t squared plus 38t, okay, and if I go 240 minus 265, all right, that's negative 25 equals 0. So what we have is this is my A, this is my B, this is my C, all right, plug that into I keep saying Pythagorean theorem, quadratic formula. So t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So this would be negative 38 plus or minus the square root of 38 squared minus 4 times a, which is negative 4.9, times c, which is negative 25. Okay, all of that is over 2 times negative 4.9. Okay, let's clean this up. We have negative 38 plus or minus the square root of. Now underneath that, we have a minus times a minus times a minus. That's going to end up being negative, right? So ultimately, I end up subtracting. So 38 squared is 1,444 minus, and we're going to go 4 times 4.9 times 25, and that's 490 over negative 9.8 when you multiply those two together. All right, now t t would be, so we have negative 38 plus or minus, okay, if I go 1444 minus 490, so now at 954, square root that, and then divide that by 9.8, you get about, sorry, I took it too far. So 1444 minus 490 is 954, and then square root that. So we're at 30.88 over negative 9.8. Okay, so now we've got two values for time. One with the plus, one with the minus. So the plus, we're going to add those, so negative, so 38 negative, okay, plus 30.88, okay, which is negative 7.12. Divide that by 9.8 negative, and we're looking at about 0.73 seconds would be the first time. Okay, we have two solutions here. Quadratic equations can either yield one solution, two solutions, or two what are called imaginary solutions, which is not really a part of this class. Now the second one that we're going to do is going to be those two. Okay, so now we're going to go 38 negative minus 30.88 is negative 68.88 divided by negative 9.8, and that's going to be at about 7.03 seconds. Okay, so let's make some sense out of this. Why do we have two times? Well, if you remember, the ball went up and down again. So basically at this point here, at this point here again would be about maybe 0.73 seconds, and at this point here would be about 7.03 seconds, and both of them are at the same height, which is 265 meters. So that's why we have two answers, one for each side of the parabola, basically. Okay, now we're looking for what is the velocity of the ball as it reaches the ground. Well, we already did that. So I'm just going to go here. Now I'm going to copy my work from part A here because I don't want to have to redo it. We just did that good stuff. Okay, that is part D. This part. There we go. There we are. Okay, now slide that on over. Okay, that would be part D, specifically the velocity right here. The speed would be the absolute value of velocity, so the speed would be just the 78.4. The velocity has the negative attached to it, so do keep that in mind. That's the difference. Okay, now part E is asking for the velocity of the ball at its highest point. Well, we already said that too. The velocity at the top, that's conceptual. That's 0. All right, we already know that. Part F, how high above the ground will the ball be when its highest point? So let's find max height. Okay, I think the easiest equation to use is probably equation number 11. Instead of delta x, it would be delta y equals v plus v naught over 2 times t. Keep in mind, delta y is y minus y naught, where y naught was already 240 meters. You have to play that into account. And v is 0 at the highest point. So what I would do is add this to the other side, and we get that y was equal to v naught over 2 times t plus 240. So let's go ahead and fill that out. So v naught all right, is 38 times t up is 3.88. Okay, and then we're going to add that to 240. So we are going 38 divided by 2 times 3.88 is 73.72 plus 240, and we get about 313 meters off the ground. So the ball is only 73 meters higher than the top of the building, but the building is already 240 meters off the ground. So 313 is the height off the ground to the highest point, not the height from the building. All right, part G, we are looking for the average speed of the ball until it strikes the ground. Now, here's the thing. It's asking for average speed, but really, if you kind of look at the answer key, it has a negative velocity, which means it really wanted you to answer average velocity. So I'm going to answer this really both ways. So, and I'm going to use this equation here, v plus v naught over 2. Okay, so now if I'm finding average speed, if I'm doing average speed here, that means I don't care about the negative direction of velocity, which means I have 78.4 plus 38 divided by 2. So 78.4 plus 38 divided by 2 is about 58.2 meters per second. That's not really what they were looking for, okay? So if I redo this and I account for velocity, then it's negative 78.4 plus 38, because the velocity is negative or pointing down when the object is about to strike the ground. So I'm going to go 78.4 negative plus 38 is now negative 40.4. Take that in half, and we're looking at about negative 20.2 meters per second. So that's really what they were looking for. They just didn't say it very clearly. Average speed does not account for direction. Average velocity does. Okay, so coming down the home stretch here, part H and I are now dealing with what happens when the ball is thrown downward, meaning V naught is now negative 38 meters per second. Okay, so let's find the time it takes to reach the ground. I'm going to do the same thing I did in part A. I'm going to find the speed, and then I'll find the time. So part H, the speed, V equals V naught squared plus 2a times the quantity y minus y naught. Okay, and this is what I'm substituting for it. Okay, this is my unknowns, what I'm looking for. This is 38. I'm going to substitute that. This is going to be 9.8. Y is 0. Okay, actually V naught is going to be negative 38. And then Y naught is 240. So that's really what I'm plugging into. Square root both sides, and V is equal to the square root of, go ahead and fix that. Okay, negative 38 squared plus 2 times negative 9.8 times 0 minus 240 is negative 240. Now you'll notice those two negatives are going to make a positive, so I'm going to be adding. Okay, and then negative 38 squared is going to be positive, so we get 38 squared, 1,444 plus 2 times 9.8 times 240 is 4,704. Add that up, and then take the square root, and what do you know? We have the same velocity. So if I have the same velocity, upon hitting the ground, okay, what's the time going to look like? Okay, now it's not going to be the same time. It's going to be shorter time, because now, if you think about it this way, looking at the picture, If I throw it upwards, it has to go up and down again, okay? If I throw it downwards, it's just that part right there. It's considerably less time, okay? But it's gonna have the same velocity. So here's what I do. I'm gonna go to that second equation. V equals V naught plus A times T, okay? And this time, this is gonna be negative 38, okay? I'm gonna solve for time. So we're gonna add 38 to both sides. Actually, I shouldn't be plugging in numbers just yet. Let me solve it for time first. So V equals V naught plus A times T. We're gonna subtract V naught both sides. V minus V naught equals AT, divide by A. T is equal to negative 78.4. That's the velocity again, same, minus a minus. So minus is part of the equation, but 38 is now negative because you're throwing the ball downward instead of upward, over A, which is negative 9.8. The negative is positive, so we're going 78.4 negative plus 38 is negative 40.4 divided by 9.8 negative is about 4.12 seconds. All right, and finally, the last part of this, letter I. We are looking for the speed of the ball as it reaches the ground. Guess what? We just did that already. So that would be this part right here. Keep in mind that might be the speed, but we really want the velocity on this. So the velocity is going to be negative 78.4 meters per second. Number 8. A ball is thrown upward from ground with a speed of 35.5 meters per second. 5.25 seconds later, after the ball is thrown, it lands on a roof of a building. What is the height of that building? So if I kind of needed a picture to visualize this, here's the building. Here's us. We throw it and it's going to land on that building. Okay, so what do we need to know about this? Well, make your list. Okay, Y naught, V naught, A, and T. Make your list. Okay, I'm going to let Y naught be 0 now because we're starting at the bottom. Okay, and then I'm going to let Y equal the height of the building, which I don't know. That is the main question mark. Okay, I know the initial speed is 35.5 meters per second, and I know the time it takes to land on the building is 5.25 seconds. Okay, I also know that this is going to be negative 9.8 meters per second squared. But I don't know the speed of the building, I don't know the height of the building. So what I'm thinking is you can jump right on. I'm looking at this. I'm looking for this. I have the initial velocity, acceleration, and time. I think we can jump right on equation number 9, which says y equals y naught plus v naught yt plus 1/2 at squared, right? Only that cancels out. So we just plug in for the rest. Okay, so V naught would be 35.5 times T, 5.25. A is negative 9.8, and then T again is 5.25, but we have to square it. Okay, so this would be, if we go, let's go 35.5 times 5.25, and we get 186.375 meters, plus a negative means we're subtracting, and we're going to go 5.25 squared times 9.8, and then take half of that, which would be 135.05625. Subtract those, we've got the height of the building. 186.375 minus 135.05625. Go ahead and take a second to put that in your calculator. All right, and we should have ended up with about 51.3 meters as Y, or the height of the building. Number 9. From the top of a building 85 meters tall, a ball is dropped. At the same time, another ball is thrown upward from the ground with a speed of 46 meters per second. How long after the balls are released will they hit? Well, there's a couple things you need to know about this. When they hit, they're going to have the same position. They'll be at the same height above the ground. And they'll do this at the same time. Oh, and by the way, they'll have the same acceleration equals negative 9.8. So there's a lot of things going on that are the same with these two balls. The only difference really is that one is being dropped from rest at the top of the building, the other is being thrown upwards. So let's go ahead and sort out this. So here's your building. Okay, and at the very top, we have a ball that's being dropped, okay, and it's gonna that ball's gonna be dropped, and then the other ball is gonna be launched. Okay, now when will they hit? It's not gonna hit right in the middle, but when they hit, they're gonna have, like I said, the same position, they'll hit at the same time, and they'll have the same acceleration. So why? I don't know it. Why not? Well, that depends on the ball. So I'm gonna basically break this down. This is gonna be why not for ball 1. Why not for ball 1 is gonna be at the height of the building, which is 85. Why not for ball 2 is going to be 0 on the ground. So ball 2 is starting from the ground. Okay, V naught, so we have V. I don't know what the final speed is right here, but V naught for ball 1 is going to be 0 because it's dropped. Okay, and then for ball 2, it's going to be its launch speed, which is 46 meters per second. Okay, got that. So what we're going to do now is we're going to create 2 equations to model each of these. Okay, so ball 1, the dropped ball, I want an equation for position as a function of time. So I'm going to use equation number 9, y1 would equal y naught 1 plus v naught A1T1 plus 1 half A1T1 squared. So that's the equation that satisfies the dropped ball, ball 1. The same equation satisfies ball 2, but with different initial conditions. So y2 would equal y naught 2 plus v naught 2 t2 plus 1 half a2 t2 squared. Okay, now let's figure out what these initial quantities are. Well, we know that y1 will equal y2. So what else do we know? That this is going to be 85 when we plug it in. That this is going to be 0, okay, and that this is going to be 0 right here. So what we can do is we can start setting some things equal, because if I know that y1 equals y2, because when they're at the same height, then I also know that this expression for y also equals this expression for y. So I'm going to set those two expressions equal to each other. So I have 1 half, no, sorry, not 1 half. I have y naught 1 plus 1 half a1 t. Now again, since a and t are the same for both, I'm not even going to bother writing a1 t1. I'm just going to write at squared. Okay, and that's going to equal, now on the other side, we have v naught 2 t2 plus 1 half a t squared, and you'll see the 1 half at squared on both sides, that's going to cancel because it's exactly the same. So what I'm now finally left with is y naught 1 equals v naught 2 times t, and solve it for t. It's going to be y naught 1 over v naught 2. Y naught 1 would be 85 meters over v naught 2, which is 46 meters per second. (85) divided by 46. Let's see, that's roughly about 1.85. 1.85 seconds. They will not only hit each other, but they'll be at the exact same heights, exact same position. Okay, that's part A. Now part B, where are they going to be? Well, pick one of these two equations. It honestly doesn't matter. Pick one of the two. So here's kind of what I'm noticing. This to me looks pretty easy to plug into, so I'm just going to choose the dropped ball. So I've got 85 plus 1 half at squared, which is going to be 85 plus 1 half times negative 9.8 times 1.85 squared. Well, 1.85 squared times 9.8 divided by 2 is about 16.77, and 85 minus that is roughly about 68.3 meters off the ground is where they're going to collide with each other. So they collide in 1.85 seconds. They also collide 68.3 meters off the ground. Number 10. A ball is thrown upward so that it barely touches the top of a telephone pole and then falls back down to the ground. The time from the release of the ball until it returns to the ground is 5.2 seconds. What is the height of the telephone pole? All right, so let's think about what we know, okay? You know this is a constant acceleration problem. So let's list our variables. I don't think we need a picture on this one. So we have y naught. That's what we're looking for. Y naught is on the ground. V, I don't know. Actually, I do know. I'll get back to that one in a second. V naught, we don't know it. Don't know the initial speed. A, of course, we know. It's the acceleration due to gravity. And time, now here's the thing. If it takes 5.2 seconds to go up and down again, and you're concerned with the height of the telephone pole, then all you really care about is the time to get up, which would be half of that time, or 2.6 seconds is what we're going to want. So time in this problem is going to be 2.6 seconds, not 5.2. So all I care about is what's going on the way up. So here's what I'm thinking. Why don't we use this, knowing that V is 0 at the top, to find V naught. And once we find V naught, then we can find the height at the highest point. So V equals V naught plus A times T. V is 0. Okay, and now what I'm going to do is I'm going to subtract V naught. Or actually, let's subtract AT. Subtract AT. So V naught is going to be equal to negative AT. So V naught is going to be equal to negative, and then A itself is negative. So negative 9.8 times T, which is 2.6. That means that we're going 9.8 times 2.6, and we're looking at a launch speed of about 25.5 meters per second. Okay, now that's not the answer, but we need it though. Okay, so now at this point, you can find height a couple ways. I can use equation number 9, y equals y naught, which is 0, plus v naught t plus 1/2 at squared. Plug in that and get y. Or you can use the fact that y minus y naught, which is delta y naught is 0, equals v plus v naught over 2 times t. I like this one a lot better. It's a little quicker, hits a little faster, and v, by the way, at the top is 0. So that would be v naught, which is 25.5 divided by 2 times the 2.6 seconds it takes to get to the top. So y, the height of this telephone pole, would be 25.5 divided by 2 times 2.6. We have about 33.2 meter telephone pole. Number 11. A ball is thrown downward from the top of a building 122 meters tall with an initial speed of 38 meters per second. What will be the speed of this ball when it reaches the ground? Again, conservation, or excuse me, I keep saying that. This is a constant acceleration due to gravity, so let's go ahead and make our list. Now keep in mind, it's starting with a ball that's being thrown downward. That means the initial velocity is going to be negative 38 meters per second. You have to account for that negative right there. So let me go ahead and make my list. Oops. There we are. Okay, so we're going to have y naught, v naught, okay, a and t. So let's figure out what's going on here. We're going to let y naught be the height of the building, which is 122 meters tall, and 0 be the ground. We don't know the speed. That's actually what we're looking for. V naught is negative 38 meters per second, again, because it's being thrown downward, not upward. A is negative 9.8 meters per second squared, and time I do not know. So I'm looking at an equation that involves those variables, and I think number 10 will do just fine. V squared equals V naught squared plus 2a times the quantity y minus y naught. We would square root both sides. Okay, and v equals the square root of what? Well, in place of v naught, we're going to put 38. We're going to put 9.8 in place of a. We're going to put 0 here, and in place of y naught, we're going to put 122. So let's go ahead and plug into this thing. So we're going negative 38 squared, and then 2 times negative 9.8. Okay, and then 0 minus 122 is negative 122. Keep in mind, negative times a negative is a positive, so you're going to be adding, and then when you square the negative, it's going to be a positive also. All right, so I am looking at 2 times 9.8 times 122 plus 38 squared is about 3,835.2. Square root that, and we get about 61.9 meters per second. Now keep in mind, that is the speed, because this object is going downward, not upward. So this is the speed. I know it's asking for the speed, but I think the question really wanted the velocity. So the velocity of the ball would just be negative 61.9 meters per second squared because of its downward direction. Number 12. You're on top of a building 44.2 meters tall. The adjacent building is 98.1 meters tall. You throw the ball upwards so that it lands on the roof of the adjacent building 4.15 seconds after the ball is thrown. What will be the speed of the ball when it lands on the roof? Okay, well, let's kind of sketch out what's going on here. So here's the first building. Here's the adjacent building. Okay, here's us. Right, and that's what happens right there. Okay, so we want to make sure as we figure out first a reference frame. Okay, where is 0 going to be in the problem? Where is everything else relative to 0? And let's list our stuff. Okay, so the ball is the only thing moving, so we really need one list. And so we have y, y naught, v, v naught, a, and t. So a is negative 9.8 meters per second squared. Y naught, I'm going to let that be 44.2 meters tall, where we're starting, and then y be the height of the other building that it lands on, which is 98.1 meters tall. Okay, meaning 0 is down here at the bottom. Okay, we want to know the speed of this ball when it lands on the roof. Okay, all we know really is the time that it takes to land on that, which is 4.15 seconds. So I don't know the initial speed, and I don't know its final speed. That's ultimately what I'm looking for right there, for the speed where it lands. All right, so let's kind of play around with this a little bit. what if I tried this? I'm basically thinking of an equation that has y in it, okay, has a in it, and will allow me to find essentially v naught. Okay, I'm thinking, what if we go with equation number 9, y equals y naught plus v naught t plus 1/2 at squared, and we use that to find v naught. Now, once we find v naught, then we can choose any other equation we want to find the speed at the top, okay? We could go and use equation number 8, which is v equals v naught plus at. Once we have v naught, v is going to be very easy to find. So let's try it. Let's go ahead and isolate this for v naught, okay? So I would have to subtract y naught from both sides, and I get y minus y naught equals v naught t plus 1/2 at squared. So I'm going to take this 1/2 at squared and I'm going to subtract it over here, and I get quantity y minus y naught minus 1/2 at squared, okay, and that's going to be equal to v naught times t. I think the last thing I could do is go ahead and divide by t, all of that, and I'll have v naught by itself. So let's try that. So v naught is going to be the difference in the height, so which is 98.1 minus 44.2, and then minus 1/2 a is negative 9.8 times t squared, 4.15 squared, all over t, which is 4.15. Let's try this and see where it gets us. All right, so I am looking to so the first part, let's subtract those. So 98.1 minus 44.2 equals, and we're going to go 53.9. Okay, minus a minus is going to be a plus. So I'm going to go 4.15 squared times 9.8 divided by 2 is 84.39. So plus 53.9. Divide that by 4.15, and we're looking at an initial speed of 33.3 meters per second. Okay, now, we didn't want to find the initial speed. Ultimately, we wanted to find the final speed, but we needed the initial speed to do it. So, now that I'm looking, let's see, we can now go v equals v naught plus at, and we're going to go essentially 33.3 plus negative 9.8 times 4.15. Okay, well, this part here, 9.8 times 4.15 is 40.67. So if I subtract them, plus a negative subtract, I'm going to go 33.3 minus 40.67, and I end up with a speed, or a velocity, excuse me, of negative 7.37 meters per second. Now, what's the significance of the negative? Well, that means as the ball is going up on the roof, it's on its way down again. If you look at the picture, the ball went up and probably went down again a little bit to land on that roof. "13. You're standing on the top of a building which is 115 meters tall. You throw one ball upward at 35 meters per second and it lands on the ground sometime later. You throw a second ball downward from the same building with a velocity of 35 meters per second and it hits the ground at a later time. which ball was moving faster when it hit the ground? Okay, well, here's the idea. The truth of it is, they're going to hit the ground at the same time. Okay, let's go ahead and support that. So, first, we're going to do a problem with an upward V naught. Okay, so Y is 0. Y naught is the height of the building, 115 meters tall. V, we don't know, we're going to find it. V naught is 35, positive 35. A is negative 9.8 meters per second squared, and time I don't know. So I'm looking at those group of equations there, which would lead me to choose equation number 10. V squared equals V naught squared plus 2 times A times the quantity Y minus Y naught. Okay, plug in. Okay, we're going to go 35 squared plus 2 times negative 9.8 times 0 minus 115. So if we do that, put that in our calculator. Okay, 35 squared, that would be 1,225. Minus a minus is a plus. So 2 times 9.8 times 115 is 2254. Add those and take the square root, and we're getting a velocity of, well, the square root of that is 58.98, or just roughly 59 meters per second. Now keep in mind what's going on there. Velocity is downward, it's negative, so there's my velocity when I throw the ball upward, right? Now what happens when I throw the ball downward? Let's find out. Downward V naught. I'm going to go ahead and cut this problem in half, separate it, just so we can organize it better. Okay, same list. Y, 0. Y naught, 115. V, don't know, looking for it. V naught is now negative 35 because you're throwing it downward. A is negative 9.8. And T, again, we don't know. But I'm going to be focused on that group right there, which leads me to believe I would use, again, equation number 10, sorry. So V squared equals V naught squared plus 2A times the quantity Y minus Y naught. Okay, in this case, I'll take the square root of both sides, and V equals the square root of negative 35 squared plus 2 times negative 9.8 times 0 minus 115. You guys can all tell this is giving you the same thing. Because if I square negative 35, I'm going to get the same result. I'm going to get negative 59 meters per second squared. Well, 59 is the square root, the speed of it, but the velocity is negative because it's pointed downward. So the answer is the balls are going to be moving at the same speed when hitting the ground. Number 14. We're driving a car down a highway with a speed of 31.5 meters per second. You hit the brake and skid to a halt. Halt means, of course, final velocity equals 0. You stop the car in 5.2 seconds. What will be your acceleration part A, and how far will you have moved from when you apply the brakes until it stops? All right, this is clearly a constant acceleration problem. Make your list. All right, your list should have looked like this. X, X naught, V, V naught, A, and T. Let's take a look at that list one more time. X is how far. I don't know what that is. That is the answer to part B. X naught, we'll assume it starts from 0 because we weren't told otherwise. So when we apply the brakes, we'll call that the initial position, and then we'll figure it out from there. V final is 0 because we're coming to a halt. We're stopping. V naught was the initial speed in the problem, 31.5 meters per second. Rate of acceleration, well, that is our answer to part A. And time, well, we do know time. Time is 5.2 seconds. Okay, so to find our rate of acceleration, I'm thinking go ahead and use that group of 4 right there, because you know those variables, and looks to me like you could use, well, how about you pause the video and see for yourself? You should have chosen equation number 8. V equals V naught plus A times T. Go ahead and subtract V naught both sides. V minus V naught equals A times T. Then we will divide by T to get A. So A equals V, which is 0, minus 31.5 over T, which is 5.2. So 31.5 over 5.2 is roughly about negative 6.1. Yeah, about negative 6.1 meters per second squared. Okay, now part B says how far will it have moved? Well, you could use equation number 9 or equation number 11 if you want. Delta X equals V plus V naught over 2 times T. You know that's going to come to a stop, and you know that X naught, right, also equals 0. So this is just going to be X. So X would equal, what's left over? V naught times T over 2. Let's plug into that. V naught, 31.5 over 2 times 5.2. 31.5 times 5.2 divided by 2 equals, and the vehicle went about 82 meters far before it came to a stop. Number 15. You're rushing to the train station to catch your morning commute. The train leaves the station from rest with an acceleration of 0.6 meters per second squared. You arrive at the station exactly 4 seconds after the train leaves, and you immediately start running with a constant speed of 8.5 meters per second. How long does the train leave the station? Do you catch up with the train? B, how far does it take you to catch up with the train? And C, what would actually be the minimum speed you would need to run in order to catch the train at all? Well, this is the first time not the first time, this is one of the times we're using multiple problems in the same reference frame and with multiple motion. So we have to sort it out and organize it. So let's do kind of a chart for you. So actually just do the train first. So the train is moving with constant acceleration. So let's make our list. The train, we would have x, x naught, 0. I don't know what that is. V naught starts from rest. A for the train is 0.6 meters per second squared, and T I don't know either. Something you got to consider when you are trying to catch the train, catching up with the train means a couple things. Number one, same position X, same time T. Okay, so we were going to be setting our positions equal to each other and ultimately solving for that time it takes. So that's the train. Now, according to this, I'm looking at position as a function of time, and that screams equation number 9. So x equals x naught plus v naught t plus 1/2 a t squared, where this is 0 and this is 0. So for the train, we know that, and right here we have 1/2, okay, of a, which is 0.6 times t squared. Now I'm going to leave that alone for a minute because I'm going to now go ahead and put together something for you, because you're running, but you're running now with constant velocity. So you don't have the same list. You just have x, v, and t. Again, you don't know this, and again, you don't know that. They'll be at the same position as the train at the same time, but moving with different kind of motion. Your velocity, on the other hand, is 8.5 meters per second. Well, the only equation that would go with this, of course, is velocity equals position over time. And if we solve for x, it's going to be your constant velocity times time. Now, here's something to consider, though, that we didn't consider yet. Remember how you get to the train and you arrive 4 seconds after the train has arrived? So your t, your time, is going to be time for the train minus 4. You have to account for that. So instead of just t, it's going to be t minus 4. All right, now at this point, let's go ahead and we're going to equate our positions. X equals x, the positions are the same, therefore the expressions for each position will also be the same. This means, that 1/2 times 0.6 t squared equals v, which is 8.5 times t minus 4. Well, I'm going to go ahead and get rid of the fraction there. And I end up with, okay, this is part A, mind you, I end up with 0.6 t squared equals, well, 8.5 times 2 would be 17. Now I'm going to distribute the 17. So 17t, so distribute that, and then go ahead and multiply 17 times t, and then 17 times 4, right, would be 68. So minus 68. Okay, so now what I'm thinking at this point, you have a quadratic, so we need to go ahead and make it look like standard quadratic form. Remember, standard quadratic form is ax squared plus bx plus c equals 0, so you got to get 0 on this side. Okay, remember, instead of x, we have t. Okay, but it's the same idea. So what I'm going to do that is I'm going to subtract 17t over here, and I'm going to add 68 over here. That's going to give me 0 on the right. So I get 0.6 t squared minus 17t plus 68 equals 0. That means this is going to be A, this is going to be B, this is going to be C, and let's quadratic formula this thing. Ready? Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, now let's go ahead and plug in for quadratic formula. T is going to be negative, so negative is part of the equation, and negative 17 is what we're substituting. Plus or minus the square root of negative 17 squared minus 4 times A, which is 0.6, times C, which is 68. Okay, all of that is over 2 times A, which is 2 times 0.6. Okay, add those, we get 17 plus or minus. So I'm going to go 17 squared. So under the radical, I got 289. Okay, I'm going to be minusing here. 4 times 0.6 times 68. Okay, and that would be 163.2 over 2 times 0.6 would be 1.2. Okay, now we have two possible answers. So T is equal to 17, okay, plus or minus, now we're going to go 289 minus 163.2. 125.8, square root that, and we're looking at about 11.2. Okay, now you're going to have two possible answers here. One possible answer with the plus, the other with the minus. So let's go 17 plus 11.2 is 28.2 divided by 1.2, and we get T equals 23.5 seconds. That's one possible answer. And I will explain physically how these two answers are both actually possible. Okay, the other answer is the minus. So we're going to go 17 minus 11.2 equals 5.8. Divide that by 1.2, and you get T equals 4.83 seconds. Now that's the one that's actually more likely. So while both of them are actual answers, the first one is going to be really the one that you so let's make sense of this, okay? So the train is accelerating, is picking up velocity, right? Remember, accelerating at 0.6 meters per second squared, and you're running after this thing, okay? And yes, the pictures are not drawn to scale. You're not as big as a train. The velocity that you have is 8.5 meters per second. So what's going to happen is, basically, you would have caught the train 0.83 seconds after it started moving, okay? Now, what is the 23.5 seconds? Well, imagine this. Imagine you keep running at that constant speed past the train. You're all the way over here, but the train has now built up speed, because remember, it's accelerating, and finally catches up to you. That would be the second time you are at the same position. Okay, so I know it's kind of a crazy answer, but that's the rationale behind the two answers for part A. All right, now part B is asking for how far. So you're going to pick one of those x's. Just pick one, it doesn't matter. You could pick this one, or you could pick this one. They're both pretty easy to work with. I'm just going to go pick your value of x. So that means B, x equals 8.5 times t minus 4, which would be 8.5 times 4.83 minus 4. So 4.83 minus 4, 4.83 minus, 4.83 minus 4 is 0.83 times 8.5 is 7.06 meters per second. So that would be one speed. That'd be one velocity you have. That would be the velocity, or why I say meters per second, I'm sorry. That would be the first position that you catch the train. So 7.06 meters later, you would catch the train pretty much right away. Okay, now if you pass the train and you let the train catch up and accelerate to you, well, that would be the other one, the other possible answer, or x equals 8.5 times, well, 23.5 minus 4, right? It's the other one. So 23.5 minus 4 equals 19.5 times 8.5 would equal 166 meters. So in other words, way far down the track, I mean, you'd be tired, very tired, because you'd be running for 166 meters before the train caught up to you again. And finally, part C, what would the minimum speed be in order to catch the train? So I want you to think about this. In order to have a minimum speed, you have to have a solution with one velocity, not two velocities. Think about this. We had a solution with two times and two positions, right? So in order to get a minimum speed, we have to have essentially one time, one position, and ultimately one minimum velocity. Now, how do we do that? Well, here's how we get it done. So we're going to take our equation from before. So we have, remember, we had 1/2 AT squared from the train equals 8.5. Oh, no, not 8.5. We're looking for that. Equals V. That's what we're looking for. Times t minus 4, right? But here's what we're going to do with it. We have to make sure that, so in our, to have a quadratic solution only have one solution, you got to remember how a quadratic formula works. So plus or minus the square root of b squared minus 4ac all over 2a. So I want you to think about this. If this whole quantity here under the radical, which is called the discriminant, the b squared minus 4ac, well, if b squared minus 4ac equals 0, then what does that mean? That means you don't have a radical anymore. That means you don't have a plus or minus. You just simply have t equals negative b over 2a, which is one time, one position, and therefore one minimum velocity. That's what we're looking for. So we are going to essentially fill this out, okay? We're going to fill this out and then solve for v. So here's what I'm thinking. First of all, distribute that. We have 1/2 a, well, what was that part before? We had 1/2, well, 1/2 of a was 0.3 because a was 0.6. So we have 0.3 t squared equals v times t minus 4 times v. Okay. Now, what I'm looking at here, I want to get this, I want to figure out what my a, b's, and c's are. So I'm going to subtract this term over here, and I'm going to add this term over here. And I get 0.3 t squared minus v times t minus v times t plus the 4 times v right here. So what this would mean is this would be a, this would be b, and this whole term here would be c. And we're going to plug those in. So let me color code them so you can see them better. So a is the yellow term, b is the blue term, negative b, and c is the gray term over here. And we're going to plug those in for gray, blue, and yellow right here. That's ultimately what we're doing. We're filling out b squared minus 4ac equals 0, and we're going to essentially find one value for velocity if we do this. So b, what is our b term? It's negative v. Okay, and we got to square that because that's part of the equation there. Minus 4 times our a term, which was 0.3, okay, times our c term, which was 4v. Okay, and that's going to ultimately equal 0. So we end up with the negative v squared would be v squared minus, now you are looking at 4 times 4 is 16 times 0.3. Well, that's 4.8. So 4.8 v, okay, equals 0. And what we could do is we could factor that. No quadratic formula needed here. No, no, no. The greatest common factor of both, of course, would be v. So I factor out a v, and I'm left with v minus 4.8 equals 0. My two solutions would be v equals 0, which, yeah, that's not really going to help. We want an actual speed. So our minimum speed would be v minus 4.8 equals 0. Add the 4.8 to both sides. And our minimum speed would be 4.8 meters per second. Okay, challenging question for sure, but last time I checked, you guys need to be challenged. Please remember to come by and ask me questions if you're stuck on anything. I hope you found this tutorial to be helpful. See you next time.